In this video, we'll generate the trend line and dataset of EXPONDIST decay function over values of lambda from 1 to 5. So we have these values of data validation, list of items from 1 to 5. 1, 2, 3, 4, 5, and save. So these are values of lambda from 1, 2, 3, 4, and 5. Begin with 2. And we use array formula. Array formula, EXPONDIST of the x values over values of lambda, and 0 because this is a probability density function. So it's a decay. And we'll chart this. Insert, chart. We will use scatter chart. And show the trend line. And the trend line will be exponential. And show the equation. That's 2 minus 2x because our value of lambda is 2. We will also regress it using LOGEST. So this is equal to LOGEST data y and data x. So we have 2, that's our b0, and our b1 will be ln of this value. That's negative 2. So this is our b1, negative 2. Next, we use the exponential function, which is equal to array formula exponent of x. And there's lambda inside, so we factor in lambda times lambda. And there's a negative sign inside, so that's negative. And right up in front of x is also lambda. So that is, there's a lambda. So times lambda. Enter. Now they're on the same line. But there's no equation. So we have to change the chart, edit, and series, trend line, exponential, and equation. So they are the same equation. And we'll use LOGEST to calculate the, the regression coefficient. So LOGEST, data y, and data x. Enter. And we calculate for b1, which is ln of exponent b1. And they are the same. Next, we calculate the Taylor-Maclaurin SERIESSUM expansion, where it's the summation of a times x to the power n. And this is our a, the coefficient, and our n will start from 0 to infinity. 1, 2, 3. So we can go as far as maybe 15. Yeah, 15 is good. And our series sum. So array formula, series sum of the x values raised to the power n, where n starts from 0, increment up to infinity, incremented by 1. And the coefficient will be this range. Now we calculate the coefficients, which is equal to array formula Starting with numerator, negative 1 to the power n times lambda raised to the power n plus 1 and plus 1. Enter. Now we continue with the denominator. Divided by factorial n. Enter. There's no equation, so we enter the equation here. Edit chart and series. The trend line will be again exponential and show the equation as labeled. Now they have the same equation. We can calculate also the regression coefficient using logest data y and data x. There's already an error because it's only and this expansion is only an approximation. So ln of exponent b1. And there's already an error. So we begin with lambda equals 1. At lambda equals 1, they're the same, negative 1, and b0 is 1. The same. At lambda equals 2, there's already an error here, but they're still the same. The trend lines are the same. At lambda equals 3, there's already an increasing error on the Taylor-Maclaurin series expansion because it's only an approximation, but they're the same. Negative 3 for b1 and 3 for b0. At lambda equals 4, the error is now increasing, and that's our b1 is negative 4, our b0 is 4, and the trend lines are the same. B and lambda equals 5. Now we have a big error. Although the trend line shows a slight error, but our regression coefficients already differ. This completes the use of array formula, EXPONDIST, and the Taylor-Maclaurin SERIESSUM expansion to generate the trend line of the EXPONDIST decay.